Have you ever wondered what makes up the atoms in your body? What gives each element its unique identity? The answer lies in a subatomic particle known as the proton. The story of the proton's discovery is one that spans centuries, involving numerous scientists and experiments. It all began in ancient Greece, where philosophers like Democritus proposed the idea of indivisible particles, which they called atomos. However, it wasn't until the late 19th century that the concept of the atom began to take a more concrete form. In 1897, British physicist J.J. Thomson discovered the electron, a negatively charged particle present within atoms. This led to the plum pudding model, where atoms were thought to be a positively charged pudding with negatively charged plums or electrons scattered within. But this model was soon challenged. In 1911, Ernest Rutherford and his team conducted the gold foil experiment, wherein they bombarded thin gold foil with alpha particles. The unexpected deflection of some particles led Rutherford to propose a new atomic model. He suggested that the positive charge and most of the atom's mass were concentrated in a central core, the nucleus, with electrons orbiting around it. Ernest Rutherford is credited with the discovery of the proton in 1917. He observed that when alpha particles were fired into nitrogen gas, hydrogen nuclei were ejected. Since hydrogen's nucleus is made up of a single particle, he concluded this particle must be the proton, a positively charged component of the atomic nucleus. Protons, it turns out, are quite fascinating. They are stable subatomic particles with a positive electric charge of +1 e. They are present in the nucleus of every atom and provide the attractive electrostatic force that binds atomic electrons. The number of protons in the nucleus determines the atomic number and the chemical characteristics of an element. But there's more to protons than just a positive charge. They are composite particles made up of 3 valence quarks and are classified as hadrons. The quarks are held together by the strong nuclear force, mediated by particles called gluons. Protons have a measurable size and a root mean square charge radius of about 0.84, 0.87 femtometers. Free protons can occur on Earth and can bind to electrons to form ions. They are also used in accelerators for proton therapy and particle physics experiments. To summarize, protons are integral to our understanding of the atomic world. Their discovery helped shape the atomic model, and their characteristics define the identity of elements. They are composite particles made up of quarks and held together by gluons. Protons are present in the nucleus of every atom and determine the atomic number and the chemical characteristics of an element. They have a positive charge, a measurable size, and an important role in various scientific and medical applications. Stay tuned in Chemistry View. So the next time you ponder the question, what's in an atom? Remember the humble proton, a tiny particle with a colossal impact on our understanding of the universe. See you in next video.